did it work? Right? You should recognize that. If you recognize it, yeah, something happened here, I screwed up, you know, that was more acceptable, I'd say. Okay? Get the B matrix, well, that's P inverse, which is 0, 3, 1, 3, and then it ends up being 0, 1, which is right 4 each one. Should all zeros except for 1 for the last one. And then for the C matrix, that's C matrix times transformation. And it ends up being 3, 2. Aha. Well, I erased our transfer function for this, but those are the coefficients in the numerator. All right. Oh, okay, this looks good. Okay. Questions on that? Number 10. This is trying to make this a really simple one. What is all you have to do? Get an observable. If I have it in controllable form, put it in an observable form. There's just some transposes. You do not need to find information matrix or observable form if I have it in controllable form. Like this. Simply the transposes of this. So this was 0, 1, 0, 1. Now here's my coefficient characteristic gradient of 0, 1. P is 3, 2. And C was 0, 1. Real easy to put in observable form if I have a controllable form. Some of these use the transformation, which is really doing transpose of what's called this. And that'll work as fine too. And you go through this exact same thing here. Okay. Questions on that? Okay, number 11. There will be suitable closed loop routes to satisfy the following conditions. Percent overshoot less than or equal to 4.33%. And I want to be someone time 2% someone time. Equal to 2 seconds. A little bit simpler here, so it may have equality. Okay, percent overshoot. That means damping ratio. This is a nice way of doing this. It's the natural log of overshoot, but not in percent. A couple of you guys did 4.3. No. 0.043. Not percent there. Over pi squared plus natural log squared of 0.043. Obviously, placed it in a calculator. A couple of you said my calculator died, whatever. I think you should carry an extra calculator here. So if your calculator does die, please say so. We'll try to accommodate, borrow one from someone else. Fair enough, the new birthday present iPhone has a neat calculator in it. scientific one too. Spreadsheets too, you can't read anything, it's too small. Then we put that money in. This is about 20 seconds. Okay. 2% settling time is 4 over the real part of the root. I think we've had some trouble calculating this. If 4 over sigma is equal to 2, sigma is equal to 2, not 8. All right. How many people have down there? 8. Well, I don't know if you can write it out by hand if you need to. Okay. You can actually calculate this, or you might recognize something. If I have a damping ratio of 0.707, that's equal to rate of D. If not, okay, calculate it out. This is equal to zeta omega n. I know zeta, calculate omega n. Omega d is omega n square root of zeta squared. You know that, calculated all out. So, a perfectly great point is minus 2 plus minus 22. 4. No matter what you chose, this will always stay the same because that's an equality. But my J2, it could be 1, J 0.5, whatever. It'll never be bigger than 2, though. Okay. And the last one. People did this pretty well, except for possible math problems. All those little buggers. Gave you desired roots. I want minus 3 and minus 2. So that says my characteristic equation is s squared plus 5s plus 6. That's my desired characteristic equation. Always you can do this. 2 by 2, you can just do it by brute force. Okay, it's not too hard to do. You can also use acronyms, which do both ways. Let's do it by just simply, since 2 by 2 brute force, because they have 2 equations, 2 of those, easy to solve. My closed loop A matrix is going to be A minus B times K, which is 0, 2, 0, minus 1. And make sure you copy these right. Somebody can drop off a minus sign at this point, and you're getting tired. I'm going to put minus signs in the 4th page of the desk. P matrix 1, K is K1, K2. This 0, 2, 0, 1 minus K1, K2, K1, K2. And then subtract, right? Problems there. So this is 0. Oops, I'm sorry. It's K1. 2 minus K2 minus K1 minus 1 minus K2. That's the closed loop A matrix. Then to find the characteristic equation, take SI minus A, the determinant of that. So I'm going to find the determinant of S plus K1 minus 2 plus K2 plus K1 S plus 1 plus K2. And I say there's a lot of messing of minus signs there. Be very careful on that. 2 by 2 determinant is pretty easy. This times that. S plus K1 times S plus 1 plus K2 minus K1 minus 2 plus K2. I've got the minus sign there. Determinant. Right? Backwards is negative. Right? Now, multiply this out. Be careful on it. I did a whole bunch of parts and eliminated all the things that we result. That the K1 times K2s cancel out. You get your signs right. If you didn't have your signs right, you didn't cancel out. Well, that says this must be equal to 6, so K1 is equal to 2. Put in 2 here, this whole thing must be equal to 5. So 1 plus K2 plus 2 equals 5, or K2 equals 2. Maybe you had trouble adding that up. So, no excuses for not being able to do your sums, especially with nice whole numbers. Okay, Ackermann's method. In this case, I need 2 things. One, the n matrix inverse. 2 by 2 is not too hard. You take your probability matrix, find the inverse of it. And then the one where problems show up is finding this characteristic equation with the A matrices in here. Right? So this becomes A times A is 5 times A equals 6 times the density matrix. Right? So A times A ends up being to 6807. And people did that as most likely where you made error. Just calculate this thing. Try to say, hey, you got the method right, that's what's important. Then you put in Ackermann's formula. It says that 1, 2 is equal to, well, 0 except for the last one, 2 by 2, so it's just 0, 1, times m inverse, which is this 1/3, 2/3, 1/3, minus 1/3, 6802. And indeed, you'll get to 14. Actually, it's easier to do with math. You can actually do matrix multiplication. So I hand it kind of pain. Yeah.
I think there's a 2 instead of 7 in that matrix. Right there. You wrote it
Right
right
here.
here.
Yeah, it is. You're right. It is a 2. Sorry, my eyesight's off. Only one eye. Okay. All right, you know this little test and with explanations about 40 minutes. Do yourself right, if you have any questions about things you graded or I missed something, that's easy to do times, please bring it in. But people did real well. Alright. Next part of this design process.